Hello guys and girls, today it's a Friday and we have a grade 10 mathematics video tutorial. In this video we'll be revising the September 2022 common test. So we will be doing financial mathematics and probability for part 1, and for part 2, which will be available later, we have analytical geometry, statistics and a bit of trigonometry. Alright, before we start, I would just like to let you know that on Fridays we always have a grade 10 video tutorial. So if you are new here, just make sure you subscribe to the channel and turn on the notification so that you will be notified when a new video is available. Also, if you like our videos, please do click on the like button, or you can even say something on the comments. Why? Because we get feedback on if we really should keep on posting video tutorials for the grade 10s, or people are just not interested in these student tools video tutorials. You don't have to do it all. Either you like or you say something. But if you got time, of course, you can do it all. Okay, with that said, let's dive into today's revision. Question 1, we have 1.1, which says Tyler decides to purchase a sound system which costs 7,999 rands on hire purchase agreement. Right, so here we're told about Tyler, who has purchased a sound system on hire purchase. What is hire purchase? Hire purchase is a system in which a person pays for something in installments while having the use of it. So here Tyler has purchased the sound system which costs 7,999. And then 1.1.1 says if Tyler pays a 11% deposit, calculate the balance after Tyler has paid the deposit. All right, so now let us first calculate the 11% of the total cost of the sound system. So 11% is 11 over 100. And then we'll multiply that with the total cost of the sound system. So what is 11% of 799? We will calculate that on our calculator. All right, so on our calculator, we have 11 over a 100. All this is multiplied by a 7,999. So that is equal to that. Okay. That is an 879.89. So we have 879.89. Okay, so that is 11%, which is what Tyler has paid as a deposit. So the question said we must calculate the balance after Tyler has paid the deposit. So that means we will say 7,999 minus 879.89. So here we'll borrow. We have an 8, we have 10 here, we have 10 here. So 10 minus 9, that is a 1. 10 minus 8, that 9 minus 8, that is a 1. And we have 8 minus 9, we'll borrow from here. So we are left with an 8 here, and then we have 18 over there. So 18 minus 9, that is a 9. Put a decimal point over there. And then we have 8 minus 7, that is a 1. We have 9 minus 8, that is still a 1. And then we have 7. So this is the balance after Tyler has paid the 11%. That is a 7,119 and 11 cents rands. So that is what Tyler is supposed to pay after the deposit. And that is just how we do 1.1. All right, let's proceed to 1.1.2. 1.1.2, the store charges Tyler 20% interest per year. With the loan payable over 4 years, calculate the amount that he will have to pay back. All right, so here we are told that Tyler is charged an interest of how many percent? It's 20%. So what is 20%? 20% is equal to a 20 over a 100, which is a 0.2. And as we proceed, we are told that the loan is payable over 4 years. So the loan is payable for over 4 years. And on 1.1.1, we were told, we actually got that Tyler has a balance of 7,119 and 11 cents. So that will be our principal amount. So now we will use a formula to calculate the amount that he will have to pay back. So we have this simple interest formula to calculate that. 1 plus I multiplied by n. So we will use this formula to calculate the total amount that he will have to pay back with the interest. So the principal amount will have to be the 7,119 and 11 cents. We multiply that with the 1 plus I is 0.2 multiplied by n. So that is 4 years. Close our bracket. So what is the accumulated amount after? So we will punch that in our calculator. So in our calculator we have 7,119.11 multiplied by a 1 plus a 0.2 multiplied by a 4. Close bracket, close bracket. So what is that equal to? That is equal to a 12,814 and how many cents? 40 cents. To 2 decimal places, that will be 40 cents. So Tyler will have to pay a total amount of 12,814 and 40 cents. And that is just how we calculate that total amount. Okay, now we are done with 1.1.2. Let us proceed to 1.1.3. 1.1.3, Tyler is also required to pay a monthly insurance of 30 rands and an administration fee of 12 rands. How much will Tyler's monthly repayments be? Okay, so we're told here about a monthly insurance of 30 rands. So monthly insurance of 30 rands and an administration fee of 12 rands. So let's see how much will that be in 1 month. So 0 plus 2, that is a 2, and 3 plus 1, that is a 42. So that is what he pays for insurance and administration in 1 month. But we are not done, because Tyler is also supposed to pay that 12,814 and 40 cents. So he has to pay that within 4 years, and he has to pay it monthly. So how many months do we have in a year? We have 12 months. So we'll multiply 12 months with a 4. That is a 48. So he will have to make payments for 48 months. So let us say how much he has to pay monthly on this 12,814 and 40 cents. So we'll divide this with a 48. So let's do that on our calculator. Okay, so on our calculator we have 12,814 and 40 cents. We divide that by the 48. So that is equal to 266 and 96 cents, or maybe 97 cents to 2 decimal places. So from the 12,814, he has to pay 266 and 97 cents monthly, plus the administration and the insurance. So we will add that. So plus 42. So that is 97 cents. And 6 plus 2, that is an 8. 6 plus 4, that is a 10. So that means we have 308 and 97 cents. That is the amount that he has to pay monthly. So it's a 308 and 97 cents. And that is just how we do it for this question. Next, we have 1.2. 1.2, on a trip to Florida, Aquande booked into a hotel for 4 nights. The exchange rate at the time was $1 is equal to a 16 rands and a 7 cents. The cost per night was 450. How much did she spend in rands for the 4 nights? Right, so here we're told about Aquande who booked into a hotel for 4 nights, and the exchange rate was a $1 is equivalent to a 16 rands and a 77 cents, and the cost was $450. So if the cost was $450 per night and Aquande spent four nights, so that means we will multiply 450 by a 4 because he spent 4 nights. So 4 multiplied by a 0, that is a 0, and 4 multiplied by a 5, that is a 20. So we'll put the 0 and carry the 2. So 4 multiplied by a 4, that is a 16, plus the 2, that is 18. So we have 1,800. That is $1,800. That is how much it costs for 4 nights. So then the question said, how much did she spend in rents? So we know that in dollars, she spent $1,800. We want this one, which is in rents. So how much did she spend? So to get 1,800, we have to multiply the one with a 1,800. So we'll do the same thing on the other side. We will multiply 16.77 by the 1,800. So what is 16.77 multiplied by a 1,800? Okay, 16.77 multiplied by 1,800. So that is equal to a 30,186. So that is how much she spent in rent. So that is 30,186 rands for 4 nights. Just for 4 nights. That's a lot. I mean, anyways, let's proceed to 1.3. 1.3, after 7 years, an investment increased to 95,798 and 35 cents. If the interest rate was 8.25% per annum, compounded annually, calculate the amount initially invested. So in this question, to calculate the amount initially invested, what formula are we going to use? Are we going to use the simple interest or the compound interest formula? Obviously, we will use the compound interest formula, which is A equal to the principal amount multiplied by 1 plus the interest to the power n. All right, so why are we using this formula? We're using this formula because our interest is compounded annually. And in this case, we were told that our interest is equal to a 8.25%, which is equal to a 0.0825. All right, so this investment has increased for a certain period of time, which is 7 years. So that means our N will be equal to A7. And then that investment has increased to a 95,798 and 35 cents. So that means that is the accumulated amount. So that means that's our A. A would be equal to a 95,798 and a 35 cents. So what are we looking for? We want to calculate the amount that was initially invested. So that will be the principal amount. That is what we are looking for. So how are we going to get that? We will use this formula, the compound interest formula. So we will substitute into that formula and then get the amount that was initially invested. So for the accumulated amount, we have 95,798 and 35 cents. That is equal to the principal amount. Multiply that with a 1 plus the interest is 0.0825. So one might ask, where are we getting that 0.0825? We're getting that 0.0825 from 8.25%, which is 8.25 over 100. So that is equal to the 0.0825. So we'll put it over there. And all this is to the power 7 because it's to the power n. So now we want to make p the subject. So this is what we will do. We will divide by 1 plus 0.0825 to the power 7. 7. Both sides. So this side will also divide with a 1 plus 0.0825 to the power 7. So this side will cancel this one, such that the principal amount will be equal to that. So let us use our calculator to calculate this. Okay, so we have 95,798 and 35 cents divided by 1 plus 0.0825, close bracket, that is to the power 7. So all this is equal to a 55,000. So the principal amount is a 55,000, or the amount that was initially invested was a 55,000 rands. And that is just how we calculate it. Okay, now we are done with this question. Let us move on to 1.4. 1.4 says Linda deposits 4,500 rands into a savings account. At the end of 4 years, she adds a further 2,500 rands into the savings account. The interest paid on the savings is 7.5% per annum, compounded annually. And then we have 1.4.1, which says calculate how much money is in the account at the end of 4 years, immediately after the second deposit. All right, with such questions, it is wise to create a timeline. So now let us create a timeline for this investment, for Linda's investment. So Linda deposits 4,500 into her account, and up to 4 years where she adds an amount of 2,500. So let us create a timeline for the 4 years. So we have 4 years. 1, 2, 3, 4. So from here we have 0, 1, 2, 3. So that means we have 4 years over there. And over here, she deposits a 4,500 rands at 0. So at 0, she deposits at 4,500. So that's the beginning of her investment. So at the end of 4 years, she further adds an amount of 2,500. So here at 4 years, we have a 2,500 rands over here at 4 years. And then we're told about the interest paid on the savings account. So we have an interest of how many percent? We have an interest of 7.5% per annum within the 4 years. 7.5% per annum, compounded annually. Right, so the question here in 1.4.1 says we must calculate how much money is in the account at the end of 4 years. So as you might have noticed, here we have 4,500 at the beginning of the investment. So that means the 4,500 gains an interest for the 4 years. And then we have this 2,500. Because the question asked that we determine the amount of money that is in the account at the end of 4 years immediately after the second deposit. So that means here we are not going to calculate any interest because it's immediately after the second deposit. So that means there is no interest gained. So let us calculate here the amount of money that is accumulated after her first investment and then add this 2,500, which will have no interest gained. So now let us calculate the amount of money is accumulated within the 4 years. So we have our formula. Because it's compounded annually, we will use this formula, a compound interest formula. So P is multiplied by 1 plus I to the power n. And then we want the accumulated amount within the 4 years. So that means our principal amount is 4,500. So we will have 4,500 over here multiplied by 1 plus I. So, or the interest. So we have 7.5. 7.5 is 7.5% is 7.5 over 100, and that is equal to a 0.075. So we will put a 0.075 over here, and then we close our bracket and to the power n. So that means how many times? 4 years, because it's compounded annually. So it gains interest annually. And how many times will that be over here? Because it's 4 years. So that means we will make this to the power 4. So this accounts for the amount of money that is accumulated from this investment of 4,500 within the 4 years. But then there's also this 2,500. So this 2,500 does not gain any interest. And that's why we will just add that 2,500, because the question asked that we determine the amount of money accumulated immediately after the second deposit. So that means we're including this 2,500, but without any interest accumulated. So now let's calculate the value that we are going to get here. Right? Let us use our calculators. Okay, we have 4,500 and we're multiplying that with a 1 plus the interest of 0.075, close bracket, and that is to the power 4. And then we have that 2,500 that we're supposed to add, which gains no interest So we will add the 2,500 to get the amount of money accumulated immediately after the second deposit. So that's the second deposit of 2,500. And the amount that is in her account immediately after the second deposit is 8,509 and how many cents? 61 cents. All right, so immediately after the second deposit, she has 8,509 and 61 cents. And that's how we calculate 1.4.1. Okay, now let us move on to 1.4.2. 1.4.2 says that we must calculate how much money there will be available in the savings account 10 years after the first deposit. Right, so on the previous question, we were calculating the amount of money that is accumulated within the 4 years. And now we are looking for the amount of money that will be accumulated after 10 years after the first deposit. Right, so let us create a 10-year timeline. All right, let's remove this. We'll make this a little bit longer. So we have 5, 6, 7, 8, 9, 10. So yeah. All right, now we have that. What we know is the interest gained also from the 4th year up to the 10th year will be 7.5% per annum. And we also know that on the 4th year, the amount of money that is in her account is 8,509 and 61 cents. So now we will calculate the amount of money that will be accumulated from the 4th year up to the 10th year. So for how many years? 1, 2, 3, 4, 5, 6. So we will calculate the amount of interest that is accumulated within the 6-year period with an investment of 8,509 and 61 cents. So we'll use our compound interest formula, which is A equal to P1 plus I to the power n. So we have our principal value is 8,509 and 61 cents. So that's our principal value or amount. So we'll multiply that with a 1 plus the interest is a 0.075. And all that is to the power, how many years? 6 years. So from here. And remember that we're using 8,509 and 61 cents because here, that's the amount of money that is in her account. So that is why we're using this amount as the principal amount. So that's why we will calculate the interest accumulated here within the 6 years. So now let us punch this into our calculator so that we can see what we get or the amount of money that will be available in her savings account after 10 years. So now let us do that. Right, so we have 8,509.61 and we multiply that with a 1 plus a 0.075 to the power 6. So how much is that? That is a 13,132 and 89 cents. 13,132 89 cents. So that's how much she has in her savings account after 10 years. All right, so that is just how we calculate 1.4.2. All right, now let us proceed to the next question. Okay, now we are on question 2. Question 2, we have 2.1, which says a bag contains yellow and blue marbles of equal size. The probability that a marble chosen at random will be yellow is 1/6. Right, so we have a bag which contains yellow marbles, and then the other one contains blue marbles. And then we're told that the probability that a marble chosen at random will be yellow is 1/6. So over here we have 1/6. That's the probability that if a marble is chosen at random, that marble that maybe that will be picked is gonna be a 1/6. The probability for that will be a 1/6. So logically, if we have 1/6 here for the probability of the yellow marbles, what does that mean for the blue marbles? That means the probability that if a marble is chosen at random, that marble will be a blue one. It means the probability will be a 5/6, because if we have 1/6, that means we have 5 left out of 6. And then we have a question here, 2.1.1, which says, it is given that there are 102 marbles in the bag. How many of them will be blue? All right, so we will use the probability of the blue marbles. So the probability of the blue marbles is 5/6. And we will multiply that with the total amount of marbles that are in the bag. So that is a 102. All right, so what is 5/6 multiplied by a 102? Let us first divide here with a 2. So 2 here goes here 3 times, and 2 goes here 5 times, and 2 goes here 1 time. That is 51. And then we have this, so we can still divide with a 3 here goes once, and 3 goes here how many times? That is 17 times. So 17 multiplied by a 5, 17 multiplied by a 5, that is 5 multiplied by 7, that is a 35. So we will carry the 3, 5 multiplied by a 1, that is a 5 plus a 3, so that is an 85. So that means our final answer is equal to 85. 85 what? 85 marbles. So that's the amount of blue marbles that you would find in the bag. All right, now we're done with this question. Let us proceed to the next one. 2.1.2, we have another case where we're told that if there are 26 yellow marbles in the bag, how many of them will be blue? Remember that the probability for the yellow marbles is equal to a 1/6, and the probability for the blue marbles is equal to a 5/6. So in this question, we are told that if there are 26 yellow marbles in the bag, how many of them will be blue? So here we are given the amount of yellow marbles. We're not given how many marbles are there in total, and we have to determine those of which are blue. All right, so how are we going to do that? We will do that by creating an equation. So we'll create an equation which looks like this. So we will let the total amount of marble to be an x. And with the x, when multiplied with the probability of yellow marbles, we will get the total amount of yellow marbles. So that is 1/6, which will be equal to the 26 yellow marbles. Because if you multiply the probability of the yellow marbles and the total amount of marbles that are in the bag, you get the 26. So what we want to get is the total amount of marbles that are in the pack so that we can determine the amount of marbles which are blue. All right, so now let us do this. So x multiplied by 1 over 6 equal to a 26. So that is an x over 6 equal to a 26. So now we will multiply everything with a 6 to get rid of the fraction. So we multiply with a 6 here and multiply with a 6 here. So this will cancel this such that x will be equal to a 26 multiplied by a 26. 26 multiplied by a 26, 6 multiplied by a 6, that is a 36. We carry the 3, 6 multiplied by 2, that is a 12, plus a 3, that is a 15. So x is equal to a 156. So 156 is the total amount of marbles in the bag. All right, so now we have the total amount of marbles that are in the bag. So how do we determine the amount of marbles that are blue? Because we have 156 in total and minus the yellow marbles, that is 26. So we'll subtract the 26 and that will give us the amount of marbles that are blue. So 156 minus 26, that is a 130. 130 what? Blue marbles. All right, that is just how we determine the amount of marbles that are blue. Okay, now we are done with this question. Let us proceed to 2.2. 2.2, we have a question which says complete the following, and we have 2.2.1, which says for exhaustive events, we have the probability of A or B equal to that. All right, so we have exhaustive events. What are exhaustive events? Two events are exhaustive when their union is equal to the sample space. All right, so that's the definition for exhaustive events. Two events are exhaustive when their union is equal to the sample space. The sample space is equal to A1. So the probability of A or B is the same as saying the probability of A union B. So from this definition, we get that two events are exhaustive when their union is equal to the sample space. So the sample space is equal to A1. So the probability of A or B, or the union of these two exhaustive events, will be equal to A1. And that is just what is required for this question. Okay, we have 2.2.2 next. 2.2.2, we have for mutually exclusive events. And then we have the probability of A and B equal to something. All right, so first let us define what are mutually exclusive events. Mutually exclusive events are events that do not occur at the same time. There is no intersection between these two events. Right? That's the definition for mutually exclusive events. So here we have the probability of A and B. So the probability of A and B can also be written as probability of A intersection of B. So that means here we are describing the probability of the intersection of A and B. So for mutually exclusive events, there is no intersection between A and B. So that means the probability of A and B will be equal to a 0. And that is just how we answer this question. Okay, next we have 2.3. 2.3 says we're given that A and B are inclusive events. Okay, so we have A and B, which are inclusive events. So what are inclusive events? Inclusive events are the opposite of mutually exclusive events. So remember, on the previous question, we're discussing mutually exclusive events. We discussed that mutually exclusive events do not have an intersection because they do not occur at the same time. But for inclusive events, that means they have an intersection. So they occur at the same time. So inclusive events occur at the same time. And that means they do have an intersection. All right. So we're also given more information here. We're given that the probability of A or B, so the probability of A or B is equal to a 0.9. And then the probability of A is equal to a 0.6. So also we're given that the probability of B is equal to a 0.4. Calculate the probability of A and B. So we're supposed to calculate the probability of A and B. So this is what we are looking for, the probability of A and B. And we can still translate this probability of A and B as the probability of the intersection of A and B. So that's what we're looking for. We are looking for the intersection of A and B. So we'll draw a Venn diagram so that we can determine the intersection of A and B, which is actually the probability of A and B. It's one of the same thing. The probability of A and B, or the probability of the intersection of A and B, is still the same thing. So now let us draw our Venn diagram. All right, so we will have our sample space over here, and this. Here we will have the probability of A, and over here we will have the probability of B. So this is our sample space. All right, now we have that. Let us go back to the information that is given to us. Let us start with the probability of A or B. The probability of A or B, we can still translate it as the probability of A union B. So that is equal to the 0.9. So that means if we have the probability of A union B as 0.9, when we have a sample space of 1, that means out here we have a 0.1. Alright, so to determine the probability of the intersection of A and B, let us say the probability of the intersection is X. And then here on the statement, we're given that the probability of A is equal to a 0.6. So we have a 0.6 here minus the intersection. So that means here we have a 0.6 minus X. And then we have the probability of B. The probability of B is equal to a 0.4. And the probability of B over here is the 0.4 minus the X. So here we will have the 0.4 minus the X. Alright, so we know that the union of probability of A and the probability of B is equal to a 0.9. Alright, so now let us add this and have it equal to a 0.9 so that we can calculate the value of X, which is the intersection of A and B. Okay, so we have 0.6 minus X plus 0.4 minus X. Okay, we have 0.6 plus 0.4. So that is equal to a 1. And then we have minus X plus X, that is a 0. And then we have this minus X. So that will give us a minus X here. And all this is equal to the 0.9. Because the probability of A union B is equal to a 0.9. To get this intersection, we have to get X. So we have to make X the subject. So to make X the subject, we will have to take 1 from the left-hand side to the right-hand side. So how are we going to do that? We will subtract 1 and also subtract 1 on the right-hand side because we did that on the left side as well. So that means minus X will be equal to a 0.9 minus 1. So what is that? All right, so that is a negative 0.1. But then we have a negative X here. We don't want a minus X. We want a positive X as the subject of the formula. So to do that, we will divide with a negative 1 both sides. So X will be equal to 0.1 divided by a negative 1. That is a positive 0.1. So that means our intersection is equal to a 0.1. So now we can go back and erase this so that we can put the exact values that we are supposed to put here. So X is equal to a 0.1. So now we can remove the X. So X is removed. And over here, we have 0.6 minus X. So that means that's the 0.6 minus the 0.1. So what is that? That is 0.5. And then on the other side, we have 0.4 minus X. So which means that's the 0.4 minus the 0.1. So that is a 0.3. So now we can remove the 0.6 minus X and the 0.4 minus X over here on our Venn diagram. So these are the exact values that are supposed to be in our Venn diagram. So let us not forget what the question required of us. The question required that we determine this, the probability of A and B, which is the same as the intersection of A and B. Here we determine that it's a 0.1. So here we have a 0.1 as our final answer. The probability of A and B is equal to a 0.1. Okay, now we are done with 2.3. Let us move on to 2.4. Okay, 2.4. Says 205 grade 10 students have a choice of two sports, soccer, S, and hockey. Right, so we have 86 students playing soccer, 64 students play hockey, 63 play neither of the two sports. Let the number of students that play both soccer and hockey be an X. And then we have 2.4.1, which says draw a Venn diagram to represent the above information. Right, so we have this information about the 205 grade 10 students. We have 86 students playing soccer. So 86 students play soccer. And then we have 64 students playing hockey. We also have 63 students playing neither of the two sports. So we're told here that we let the number of students that play both soccer and hockey be an X. Right, so this is the information that is given to us. And 0.4.1 says we must draw a Venn diagram about this information. Right, now let us draw our Venn diagram to represent the information given to us. So we have our sample space over here, and our sample space is of students, which are equal to how many? 205. Okay, and then we have this. Yes, so this will be for soccer and this will be for hockey. Okay, the last pointer that we were given, we were told that we let the number of students that play both soccer and hockey be an X. So we will put that X over here. Here at the intersection, both soccer and hockey will be X. So to represent the number of students that play soccer, we will have 86 students. So we have 86 students playing soccer minus the intersection of those which play both soccer and hockey. So we will have 86 minus X here for soccer only. All right, so that is how we represent soccer only with the 86 minus X, which is the intersection. And that's what we're also going to do for the hockey. The students that play hockey, we have 64 students. So 64 minus the intersection, of which that intersection means those students play soccer and hockey. So we want the students which play hockey only. Hockey only will be 64 minus the intersection, which is the X. And then that pointer, we're told that 63 students play neither of the two sports. So if they play neither of the two sports, we will have them over here, 63 students. And that is just how we represent this on a Venn diagram. Now let us go to 2.4.2. 2.4.2 2. Calculate how many students play both soccer and hockey. Okay, so here we are supposed to determine the number of students that play both soccer and hockey, which is this intersection. And here we were told that we must let this intersection be an x. So we are supposed to determine the value of x. So how are we going to determine the value of x? So to determine that, we will use our sample space. So our sample space is equal to the 205 students. So 205 students, that is equal to the 86 minus x plus x plus 64 minus x plus this 63. So that is equal to the 205. 205. Okay, so we are supposed to determine the value of x. So 86 plus 64 plus 63. So what is that? All right, let me check that with my calculator. 86 plus 64 plus 63. So that is a 213. So we have a 213 over here. And then we have minus x plus x. So that is a 0. And then we have minus x here. So we have minus x. And that is equal to a 205. We want the value of x. So we want to make it the subject. So to make x the subject, we'll have to take 213 from the left-hand side to the right-hand side. So we'll do that by subtracting 213 and also subtract 213 on the right-hand side. So this will be 0 such that minus x will be equal to 205 minus 213. And that is equal to a negative 8. So here we have minus x. We don't want minus x, we want the positive x. So to get the positive x, we'd have to divide everything with a negative 1, both sides. So x will be equal to a positive 8. And that means our intersection is equal to an 8, meaning the students that play both soccer and hockey are equal to 8 students. So on our final answer, we have 8 students playing both soccer and hockey. All right, that is just how we do 2.4.2. Now let us move on to 2.4.3. 2.4.3, determine the probability that a learner chosen at random plays hockey only. Okay, so on our Venn diagram, for hockey only, we have 64 minus x. So that is hockey only. Okay, let us create some space to write on. We'll remove this. So for hockey only, we have 64 minus x. On the previous question, we got that the x is equal to an 8. So that means for hockey only, we have 64 minus an 8, which is equal to a 56. Okay, so the question said we must determine the probability that the learner chosen at random plays hockey only. So how do we determine that? So the probability that a learner plays hockey only is equal to 56 out of how many students? We have 205 students. 56 over a 205 in decimal is equal to a 0.27. And that is the probability that a learner chosen at random plays hockey only. Okay, so that is how we do 2.4.3. Now we have 2.5 next. 2.5 given A and B are mutually exclusive events. Right, so remember we discussed mutually exclusive events. On the previous question, we said they have no intersection. So those are events that do not occur at the same time. So we're given A and B, which are mutually exclusive events, with the probability of A equal to a 0.5 and the probability of B equal to a 0.4. Determine the probability of B complement. So if we were to draw a Venn diagram for this, we have the probability of A and the probability of B. So this is the sample space. A and B are mutually exclusive events. So we do not have an intersection here. All right, so if there is no intersection, that means the probability of A will exactly be the 0.5 and the probability of B will exactly be the 0.4. So the union of the probability of A and the probability of B will be the 0.5 plus 0.4. So that means probability of A union B will be equal to 0.5 plus 0.4, which is a 0.9. So of course our sample space is supposed to be A1. So that means out here we have a 0.1. So that is how our Venn diagram looks. To answer our question said we must determine the probability of B complement. So the probability of B complement, which is the probability of not B. So to determine what is not B, we'll have the 0.5 and 0.1 because B is 0.4. So we don't want 0.4, which is the B. We want what is not B. So it will be 0.5 plus 0.1, which is equal to a 0.6. So the probability of B complement is equal to a 0.6. And that is just how we tackle this question. Okay guys and girls, that marks the end of this tutorial. Make sure you join us again, same time, same place next week for another grade 10 video tutorial. Remember to subscribe to the channel if you haven't done so already, so that YouTube can let you know whenever a new video has been uploaded. Bye bye.